This video is to help you through the review assignment, just in case we don't get through all of it today. In numbers 1 and 2, you have to find the area. So I always start a problem like that with the formula. And this helps us remember that for area, we need the radius. We're given the diameter. So we want to take that and cut it in half. So 12.7 is what I'm going to use in my formula, and it says use your calculator's value of pi. So 12.7 squared times pi, 506.7. And that's given in centimeters squared. In number 2, our diameter is 14, so we want to make sure we use the radius, which is 7. So that'll be 49 times pi, and on a multiple choice, if the answers were given in pi, we would be done. So here, 153.94, or 0.9. It says round to the nearest tenth, and that's in inches, so our area is in inches squared. In number 3, we're asked to find the circumference. So I could use pi d since I'm given the diameter. D is 8, so pi times 8. 8 pi would be a multiple choice solution if the answers were given in terms of pi. Otherwise 25.1, and that's given in yards. So in number 4, we're asked to work backwards. We're given the circumference and we have to find the radius. But I'm going to start that by writing the formula the way I always do. Then substitute what I know. 37.7 inches equals 2 times pi times the radius. And I want to get the radius by itself, so I'm going to divide both sides by 2 pi. So whatever the answer to this is going to be what my radius is. So 37.7 divided by 2 times pi equals 6.000, so r equals 6, and that is inches. Now I'm being asked to find the length of each arc. So if you recall, we have a formula for that. We're going to take the degrees out of 360, and then arc length is just a portion of the circumference. So we're going to multiply that times 2 pi r, and the r in this case is 16. So once we set up our formula, it's really just a matter of plugging it into the calculator. So I'm going to put 135 out of 360 times 2 times pi times 16. And all that together is 37.7 inches. In number 6, I'm going to use the same formula, 315 out of 360 times 2 pi r, and in this case the r is 17. So 315 out of 360. Now multiply that times 2 times pi times 17. Notice I put all that in parentheses just in case. So that equals 93.5 kilometers. Number 7, we have to find some different arcs or central angles. So I'm looking at YTV. So y, and then t is the center v. So that's the angle that I'm looking for, and it's composed of this 50 and this 54. So that's like an angle addition postulate. So that equals 104. Then arc HIF, here's H, I, and then F comes around here, so I need this major arc. So I need to find all the angles that are part of it. So I'm given arc IE and with central angles, the angles are the same. And then here's a 65 that I can bring into the middle. Because my goal, I need to find what this is because it's part of the major arc I'm looking for. And I know everything else, and I know everything adds up to 360. So I'm going to take 360 and I'm going to subtract away all of the other angles. So let me go separately here and add those up. 61, 60, 33, and 65. So altogether that is going to add up to 61, 60, 33, 65. That adds up to 219. So I'm going to take that away from 360 and I get 141. So I can label that. And then HIF is composed of a 60, a 61, and a 141. So 262 altogether. In numbers 9 and 10, we're just, if we're given an arc, we name the angle. If we're given an angle, we name the arc. So we're given arc UW, which is going to correspond to angle 3. So they're checking to see if you can tell that's the minor arc and which central angle is associated with it. Arc GH, that is going to be associated with angle 1. So if they had given GIH, then you would have had to know to go the other way around. Find the length of the segment indicated in numbers 11 and 12. So it looks like we've got some chords here. We've got some right angles marked. So really the key is to know that we're bisected here and that we have a radius here. So I can also label that radius anywhere else that I need it, as long as it's a radius. So we're looking for distance x, which is a portion of this right triangle right here. So most right triangles, you can use the Pythagorean theorem to solve for a missing side, and that's what I'm going to do here. I'm going to say x squared plus 15.3 squared equals 17 squared. And to get x by itself, I'm going to subtract 15.3 squared from both sides. So that one cancels, and x squared equals, I'm going to do 17 squared minus 15.3 squared equals 54.91. And then square root both sides, and we get x equals 7.4. In number 12, let's see, I have a chord again. It's bisected because that's at a right angle. And x is my missing piece. This 18.3 is the hypotenuse. So that's going to be just like the last problem. And I'm going to subtract 14.4 squared from both sides. Now, I'm being very careful when I do the subtraction in my calculator. I don't want to subtract 18.3 minus 14.4. That will not give me a correct solution. I have to make sure that I square those numbers in my calculator. So I get 127.53 for x squared, square root both sides, and I get x equals 11.3. Alright, so numbers 13 and 14, that is the lesson that we went over yesterday. The center is always going to be h and k from our standard formula for a circle, and we remember that standard formula has x minus h and y minus k, and then that's r squared. So x minus h, and if that's a positive, that means h is -1 and k is -2. And then my r equals 1 because the square root of 1 is 1. So I'm going to go over to -1, -2. And then I'm going to make a radius of 1 unit. I'm going to sketch my circle. Okay, and number 14, I'm looking for h and k. So here I've got a +1, so that means my h is -1 and k is 2. And then my radius is the square root of 16, or 4. So I'm going to go to -1, +2, and then I'm going to go 4 units out from that point in all directions. And I'm going to use those points to sketch my circle. 15 and 16, you're kind of being asked to do the opposite. You're given the center and the radius, so you're just going to take your standard form of a circle, x minus h squared plus y minus k squared equals r squared. Same thing here, x minus h squared plus y minus -11 equals the radius squared. 17 is more of the same. So h and k are, h is -2, and then there is no k value, so that'd be 0. And then the square root of the radius is the square root of 12. So in order to know how big to draw my circle, I just want to get a rough idea of what's the square root of 12. 3.5-ish. So I'm going to go to -2, 0, and then I'm going to go 3.5 out from each of those. 1, 2, 3.5. So that's going to make my circle. And there we go. In numbers 18 and 19, we're looking for arcs and angles, and I have a feeling that we've got some inscribed stuff going on. So here is a missing angle. So let's see what I can fill in here. So this inscribed angle, angle JHK, is 46 degrees. So I know it's inscribed, so the arc is twice as big. So 2 times 46 is going to give me 92. And then I see that JL is a diameter. So I know that arc JKL is 180. So that tells me that KL is 180 minus 92, or 88. So why did I need arc KL? Because the inscribed angle KJL is cutting arc KL. So if this arc is 88, then the rule is that the angle is half of that. So that's how I get my angle is 44. So let's take a look at number 19. The missing piece is right here with the question mark. Again, I've got another diameter, so I know that TVR is 180. So if I could find arc TV, then I could subtract that from 180 and get arc VR, which is what I'm looking for. So I have this 51 degrees here, which is an inscribed angle. So I know that arc TV is twice the measure of the inscribed angle. So it's 102. So if I take 180 minus 102 and get 78, that is the measure of arc VR. In numbers 20 through 26, we're being asked to use the rules of inscribed angles and arcs and secants. So we'll go through and we'll see what each one is. So number 20, MLK is an inscribed angle. So the rule of that is that it's 1/2 of the arc that it cuts off. So 1/2 of 190 is going to give me my solution, 190, so that'll be 95. Number 21, I've got two secants, I've got an angle. I'm looking for the large arc, so the rule of that is from your flip book. So the angle is equal to 1/2 of the big arc minus the little arc. So I've substituted everything that I'm given, and I only have one thing that's missing. So I can do this one of two ways. I can multiply both sides by 2 and get rid of this half, or I could go ahead and distribute it. So I'm going to do that this time. You guys seem a little more comfortable with that. So half of QA and then half of 60. Oops, once I distribute my, well, I'll just keep that parenthesis with arc QA. And then half of 60 is 30. So let me add the 30 on both sides. I get 75 is half of QA. And then I'll multiply by 2. So QA is equal to, arc QA is equal to 150 degrees. In number 22, what I've got are two tangents here. So the formula for two tangents I'm going to have to look that up. Okay, so the equation or the formula is still just the angle is equal to half of the major arc minus the minor arc that are intercepted, and these are two tangents, so we know that they all add up to 360. So I'm going to put an X here, and then I know that the major arc is going to be 360 minus X. So I'm going to substitute in what I know. The major arc is 360 minus X, and then subtracting the minor arc. So 50 is 1/2 of 360 minus 2 X's. So half of 360 is 180. Half of 2X is X. So I'm going to subtract this from both sides, and I get negative 130 is negative X. So X must be 130. In number 23, I've got an inscribed angle, which is half of the arc that it cuts off. So 198 divided by 2 is 99.